Okay, let's talk about the urinary system. So we've got a lot of PowerPoints in this chapter, but each one of them it will only be about 15 to 20 minutes. So bear with me. So we're going to talk about the urinary system. The urinary system, its job is to eliminate excess water, salt, so sodium, and physiological wastes. And we'll talk about some of those physiological wastes once I can get my PowerPoint up and going. Here we go. So the major structures in the urinary system are obviously the kidneys that receive about 25% cardiac output at any given time to produce urine. So the job of the kidneys and the major functional unit of the kidney, called a nephron, is to filter blood and get rid of any excess water, salts, and wastes that shouldn't stay in the blood by producing urine. So the production of urine is mostly water with a bunch of solutes that you no longer need in your body. And those solutes, along with that water, get excreted. When urine is produced in the kidney, it gets transported from the kidney by way of the ureters to the urinary bladder and eventually gets excreted by way of the urethra. And there's a figure of those structures all there. So here's your kidneys. Left one sits a little bit higher than the right one because the liver sits right here. And then the ureters are those long tubes that carry urine, transport urine to the bladder, and then the urethra is what is utilized to excrete it. So the urinary system, in producing urine, is able to adjust blood volume. Remember, about half of whole blood is plasma, and 90% of plasma is water. So by changing and modifying how much water is being excreted by way of the urine or being maintained by the blood, your kidneys can adjust blood volume. And if blood volume is being adjusted, then blood pressure can be adjusted. And this is really your kidney and your urinary system they play a role in long-term blood pressure regulation. We talked about baroreceptors that play a role in short-term blood pressure regulation. Like if you stand up and get a little bit lightheaded, it takes a couple seconds for that lightheadedness to go away because the baroreceptors respond. Well, that's within a couple of seconds. So urinary system in the kidney can make adjustments to the volume of urine to either increase or decrease the concentration of urine or how dilute urine is to change blood to modify blood volume, make small changes in blood volume throughout the days and weeks and months. And by doing so, along with that water, the kidneys can exchange ions like sodium, potassium, and chloride, and other ions like bicarbonate ions to help regulate plasma concentrations of those ions as well. By doing that, but also producing or reabsorbing, modulating how much bicarbonate's in the blood and hydrogen ions, the kidneys can also stabilize pH. Remember, pH is really tightly associated with hydrogen ion concentrations, and your kidneys can filter hydrogen ions out of the blood and excrete them in the urine, which is mostly what makes urine so acidic. Conservation of valuable nutrients. A lot of nutrients that are filtered out of the blood, like blood glucose, gets actually reabsorbed back into the blood. And also the removal of drugs, toxins, and metabolic waste from the bloodstream. So there's a lot of things the kidneys can do. This functional unit of the kidney is called a nephron. Remember, we'll come back to that over and over again. The internal structure of the kidney, there's a fibrous capsule that covers the outer surface, and that's connective tissue that isolates the kidney from its surroundings, but also protects it. The renal cortex and medulla. Anytime you have a cortex and a medulla of an organ, that cortex is the outermost portion and the medulla is the innermost portion. And then renal pyramids are located in the medulla, where certain mechanisms occur. Mostly what happens in the renal pyramids is the concentration or dilution of urine as it's being produced. And then renal columns will separate adjacent pyramids. So take a look here. Right here's the capsule. This outer lighter color is the cortex. The inner, where you see pyramids, these triangular shaped structures, each one of those is a pyramid. And at the tip of the pyramid is a renal papilla. And that's where urine is produced in here between the cortex and the medulla and then transported by these structures here that we'll talk about here shortly. These are all transport structures. So the renal pyramids are located in the medulla and they are separated by a renal column. The pathway of urine produced occurs from the renal pyramid to the renal papillae and then into a minor calyx, which is what basically collects urine from each renal pyramid. Minor calyces merge into major calyces, and then major calyces merge into the renal pelvis, which is what's connected with the ureter. So I'm going to flip back to this slide. Right here's a renal pyramid. Right here's a papillae. At the tip of the renal pyramid is this papilla, where urine is sent into a minor calyx that merges into, and minor calyces merge into major calyces, and then major calyces merge into the renal pelvis, this whole area here, and the renal pelvis transports urine to the ureter. So the minor major calyces, the renal pelvis, and ureter are just ducts or tubules that transport urine. They don't have any role, they don't play any role in actually modulating what's in urine or producing urine. They just collect it and send it to the urinary bladder. The nephron, this major functional unit, it's a tiny structure, but it's the major functional unit of the kidney where urine is produced and the blood is filtered to produce urine, and exchange can occur across the membranes of this nephron. There's two major components of the nephron. One's called the renal corpuscle, where blood is sent into this renal corpuscle to be filtered, basically cleaned out. Water and dissolved solutes that are basically forced out of the glomerulus, and the glomerulus is a little tiny ball of capillaries that blood runs through and filtrate. This water and solute gets basically sent out of the glomerulus into the capsular space, which is basically where this whole area where called the renal corpuscle is where filtration occurs. That filtrate then moves into the renal tubule, and the renal tubule modifies but also carries that filtrate to where it gets excreted eventually into the minor calyx. But the renal tubule has several components as well. So let's talk about those. The renal corpuscle has two components. The glomerulus, which is a network of capillaries where blood is being sent into the nephron, basically. That glomerulus is just like, it looks like a ball of string or a ball of twine. It's a little ball of capillaries where blood moves through there and blood gets filtered, and whatever gets filtered out of the blood gets sent into the glomerular capsule. The glomerular capsule is what surrounds the glomerulus, and there's a space between the glomerulus and the capsule called the capsular space. That is where urine is first produced. It's sent from the glomerulus, those capillaries. Blood gets filtered, water leaves, and filtrate leaves. So solutes leave, like sodium ions and glucose ions, things like that, leave the blood and enter the capsular space where urine is located. So basically the water and the filtrate and all the solutes that are leaving the blood are what are creating urine in the capsular space. And in that space, from that space, urine, it's called filtrate at this point, enters the proximal convoluted tubule. This is the first section of the renal tubule, and there are three. The proximal convoluted tubule takes some of the nutrients from the renal tubule that has just come from the capsular space into the proximal convoluted tubule and actually reabsorbs it back into the blood. So reabsorption is a major function of this section of the renal tubule, the proximal convoluted tubule. From there, filtrate moves into the nephron loop, which basically exchanges ions in water to concentrate or dilute the urine that's making its way through that part of the tube. And then once the urine is concentrated or diluted, it makes its way into the distal convoluted tubule, and that continues to adjust the fluid composition by secreting and reabsorbing things back into the blood. So the major job of the distal convoluted tubule, this section of the renal tubule, drugs and toxins and things can get secreted into the renal tubule from the blood in this part, and there's some also reabsorption. So take a look here. So here's the renal corpuscle, one of two major components of the nephron. This is the glomerulus. So this little ball of capillaries, blood makes its way through this little ball of capillaries, and water and solutes leave and into the capsular space and become filtrate. That's surrounded by the glomerular capsule. So this filtrate gets trapped in here and then sent into the proximal convoluted tubule, where reabsorption occurs of some of the filtrate that left the blood, moves back into the blood, that filtrate then continues down into the nephron loop, where water and ions are exchanged to concentrate or dilute the urine. And then that filtrate continues into the distal convoluted tubule, where secretion can occur and some reabsorption. From the distal convoluted tubule, filtrate is sent into a system of collecting ducts. A system of tubes that carry tubular fluid, the fluid within the renal tubule, away from the nephron. And the first duct is called the collecting duct, and that duct carries filtrate, which is basically urine, through the renal medulla to the papillary duct, which collects tubular fluid from several collecting ducts and delivers that fluid to a minor calyx. So take a look here. If you saw, I'm going to go 2 slides back. Here's the nephron, renal corpuscle, where filtration occurs of blood. Filtrate then makes its way into the proximal convoluted tubule, where some reabsorption of water and solutes occurs. Filtrate continues into the nephron loop, where water and ions are exchanged and urine gets the filtrate, which is urine, gets diluted or concentrated, and then into the distal convoluted tubule, where some secretion from the blood into the tubular fluid occurs and a little bit of reabsorption. That tubular fluid that makes its way to the end of the distal convoluted tubule gets collected in the collecting duct. So here's a collecting duct that makes its way all the way down here. Some water can get exchanged here as well in the collecting duct, which basically adjusts the concentration of urine before it gets excreted. And then a bunch of collecting ducts make their way into a papillary duct, and that papillary duct then sends urine, filtrate, into a minor calyx. So a minor calyx would be right here. And this figure just summarizes everything I just mentioned. Blood flow to the kidney is so incredibly important because remember, the kidneys are filtering blood. The nephron is sending, there's blood being sent into the renal corpuscle to be filtered, to basically clean out the blood, get rid of any water or solutes that are no longer needed. So the renal artery is a major blood supply to the kidney, and that renal artery branches as it makes its way into the kidney to segmental interlobar arteries, arcuate arteries, and then these 3 vessels as well, cortical radiate arteries, and what's called an afferent arteriole. So the veins, I'm going to go through these 2 slides really quickly because I'm going to actually show you a figure of them next. So you can go to the figure if you want to. Blood running from the glomerulus leaves the glomerulus after it enters and heads eventually back into cortical radiate veins, arcuate veins, interlobar veins, and then a renal vein. So take a look here. Major blood supply to the kidney is renal artery, and then the renal artery branches to segmental arteries. You should understand and be able to identify these branches. So the segmental arteries branch to what's called an interlobar artery. The interlobar artery, if you see the pyramids as lobes, the interlobar artery is between the lobes, interlobar, between the lobes. And then, so here's an interlobar artery, but larger. Interlobar arteries branch to arcuate arteries. They arch or arc around the top of a renal pyramid. And then the cortical radiate arteries branch perpendicularly off of the arcuate artery up into the cortex. And I consider them kind of radiating like sun rays up into the cortex. So this is the cortical radiate artery. And then off of the cortical radiate artery branches the afferent arteriole. And the afferent arteriole is what carries blood into the renal corpuscle, into the glomerulus of the renal corpuscle. And then from the glomerulus, there's an efferent with an E arteriole that carries blood out of the glomerulus and eventually to the venous side of circulation in the kidney, where there's some similar cortical radiate veins, arcuate veins, interlobar veins, and then eventually the renal vein. So those vessels you should be able to identify on a figure. But I think the 2 most important arteries, actually arterioles, supply blood to or drain blood from the glomerulus. Remember, the glomerulus is a ball of capillaries. So blood is supplied to those capillaries by what's called the afferent arteriole that branches off of the cortical radiate artery. Blood leaves the glomerulus once it's been filtered by way of the efferent arteriole, and the efferent arteriole branches to a capillary bed called peritubular capillaries. Paratubular, around the tubule. So these paratubular capillaries surround the renal tubule, the components of the renal tubule, like the proximal and distal convoluted tubule. That occurs purposely so that the paratubular capillaries can exchange materials, substances, from the renal tubule to the blood. So where reabsorption occurs from tubular fluid to the blood, substances are moving from the tubular fluid to the blood. That happens in the proximal convoluted tubule because there's a set of capillaries surrounding them. Secretion from those capillaries into the renal tubule occurs in the distal convoluted tubule, in addition to some reabsorption. So here's the afferent arteriole. It's just branched off of a cortical radiate artery. Afferent arteriole supplies blood to the glomerulus where filtration occurs. Filtrate then leaves and heads into the renal tubule. Blood continues through the glomerulus and leaves the glomerulus by way of the efferent arteriole, which then branches to the paratubular capillaries. And these paratubular capillaries surround the renal tubule. So where reabsorption occurs from the renal tubule back into the blood, there's capillaries there to exchange. And in the distal convoluted tubule, there's also capillaries there to exchange. Mostly secretion occurs here, some reabsorption. And blood flows from the paratubular capillaries into another set of capillaries called the vasa recta that surround the nephron loop. It's also called the loop of Henle, if you see that written anywhere. And they're really important with regard to concentrating or diluting urine. Remember, the nephron loop, its major job is to concentrate and dilute urine by exchanging water and ions across the membrane from the blood into the tubule or from the tubule into the blood. So the vasa recta, so here's the paratubular capillaries, these red, they branch into the vasa recta that surrounds the nephron loop. So water and ions can get exchanged between the tubule, the nephron loop, the inner component of the nephron loop, and the actual capillaries. All right, so that's the first part. I will see you in the second lecture for this chapter. We've got 4 more to go. So I will see you soon.